Lots of awesome information. And you know what? We've had some interesting talks today about the future of forages. I think it looks pretty bright. And we're talking about young people in forage classes. We've had Bart here today. We've got Dr. Bork and myself. I teach at Olds College, and I had 90 students this year that are interested in range and forage. So that's all really positive. So this afternoon, I have the pleasure of introducing Ed Bork, and he's going to talk a little bit about some of the research at U of A. I'm assuming that's what you'll be talking about today. Awesome. So I'll turn it over to Ed.
Okay, thank you. Good afternoon, everyone. So I was asked to give an overview of what we're working on in about 15 minutes. So those of you that have seen me talk before know that I could just talk for carbon storage and carbon sequestration for probably well over an hour. So this is going to be a very high level kind of cold note summary of some of the things that we have going on at the U of A. It's not going to be exhaustive, but hopefully we'll give you a flavor for some of the things that we're doing right now, some of the things that have recently wrapped up, some of the things that are either starting or will be starting in the next 12 months. Oops. Okay. Let's go back. So I've broken this up kind of into different sections. I'm going to start out talking about carbon storage and greenhouse gas mitigation. And these are going to be kind of one-shot slides and spend a little bit of time talking about them. This first project is a project that actually takes advantage of the fact that across Western Canada, we have a number of long-term crop rotation treatments. And the catalyst for this particular study was actually the Breton plots. The Breton plots have been around since roughly 1920. So it's one of the longest running plots, certainly in Alberta and maybe even Canada. And the advantage to these plots, and what I was quite shocked to find out, is that even though we'd been collecting really detailed agronomic yield data, soil data, information on the relative inputs relative to these different crop rotations in the Breton plots, which, keeping in mind, they were intended to initially basically build up soil fertility in these gray wooded soils, these relatively nutrient compromised soils, that nobody had actually gone back and looked at the aggregate agronomic benefits of upwards of 40 years or more ongoing treatments within these. And these treatments include a number of different treatments. For example, wheat fallow, continuous cereal. It also includes continuous forage. It also includes more complex rotations of a 5-year rotation with 2 years of forage within there. So every 4th and 5th year, it goes through a perennial forage phase, and then it goes back into 3 years of annual crop. And then there's also an 8-year treatment within there with 3 years of perennial forage. So if you think about that over a 40-year period, even within the 8-year rotation, there's 5 full cycles repeated over and over and over with this incredible stream of agronomic data, and yet nobody had gone back and done basically a meta-analysis on all of that. And so a number of us, Sylvie Cadeau, Miles Dick, and myself, put in an application, and we were able to get some funding for this. Scott Jeffrey is also involved. He's an economist at the U of A. Eric Santos, who's back there, right there. So Eric Santos is actually a postdoc working on this project, and he's got the task of pulling up all that archive data and then supplementing it with some field work to look at things like root production in the different phases of those different rotations. And we're also looking at the amount of carbon and the stability of that carbon and trying to do an assessment of what's not only the net economic benefit of including rotation or forages in rotation, either short-term, 2 and 5 years, 3 and 8 years, or continuous forage, but we can also look at the relative effect of those different treatments on carbon accrual, which I think is a really interesting perspective. The other thing that we're doing with this same project is there are also long-term treatments at Lethbridge. at Glenlee in Manitoba and at Indian Head, Saskatchewan. Nobody's ever done a meta-analysis across all of those sites. So what you'll find is that there's a continuous cereal treatment at all of those locations. There's some kind of wheat fallow treatment. There's different forages included within there, but nobody's looked at whether the patterns across those different soil zones actually follow parallel results. So Eric has the unenviable job of trying to dredge all that data out of the other stations and do an aggregate meta-analysis to see and quantify what the specific benefits are of including forages in different rotations. Okay, so many of you will know that I'm a big fan of adaptive multi-paddock grazing. Early in my career, I called it high intensity, low frequency grazing. We've done a lot of work looking at the benefits of this, including on things like integrated weed control. I worked on this about 15 years ago. More recently, we've been really interested in understanding the role of adaptive multi-paddock grazing in boosting everything from forage production to carbon sequestration to greenhouse gas uptake. This particular project was wrapped up a couple years ago. We found all kinds of benefits. We've published papers, for example, documenting that ranches using AMP grazing have exhibited higher forage biomass productivity. We are finding higher water infiltration rates. These data have all been published. We're seeing changes in the soil microbial community. We're also seeing an increase in the amount of carbon, particularly within the surface soil. And what we're specifically seeing is that your humified layer, which is basically your enriched topsoil, tends to be deeper within those AMP grazed soils after they've been grazed for at least 10, in many cases, 20 years or longer under AMP grazing. So we're seeing a lot of potential benefits from this. And this is one of the reasons why we're so interested in now exploring this further within the Living Labs program. And I'll have a slide on that a little bit later. So we're seeing lots of real positive indicators coming out of this work. I just want to mention also that prior to the AMP study, we had a project which I like to call the Alberta benchmarking study. This particular study had over 100 locations across Alberta where we looked at the carbon profile, everything from how much carbon is in the above ground live vegetation, how much is in the root mass, how much is in the dead and decaying mulch and litter layers, how much is in the soil organic matter, how much is in the soil inorganic carbon component. And across those 100 sites, we had data both from grazed areas, so under ongoing commercial cattle grazing at light to moderate stocking rates. These are all public grazing leases. But then we also had it within exclosures where cattle grazing had been removed for at least 20 years, and in some cases 30 or 40 years. What's particularly interesting, we have a paper that actually I just got the reviews and I need to revise it and return it. But there are some really stunning results when you look at the net increase in carbon that's associated with the continued presence of grazing. Grazing actually continues to boost soil carbon content. And that's despite a reduction, for example, in the litter carbon mass, because we know that cattle remove vegetation, they're lowering litter, so they're removing some of the carbon stock within the litter layer. But that's offset, more than offset, by an increase in soil carbon itself. So in this particular paper, one of the things that we did is that when we took those data and we linked it to the Alberta Biodiversity Monitoring Institute's land use footprint, where we know grazing is occurring spatially across the province, we were able to do some computations as to how much additional carbon the presence of grazing is having in terms of boosting carbon stock. And we can also attach a dollar value to it because we know that carbon back in 2022 was worth $50 a ton. So for example, across those different regions that you see right there, in the Aspen Parkland, the presence of grazing is boosting carbon content by roughly 8 million tons. Now you might go, well, what's 8 million tons? Remember that every ton is worth at least $50. And you start factoring that in, the grazing induced net boost from grazing across the entire province amounts to a mind-boggling $3.125 billion. That's our estimate. So if you took away all grazing in Alberta, it's possible that our carbon stocks might actually come down by as much as $3 billion. That's actually a very good news story, and one that we need to really play out. Now, keeping in mind that this is all light to moderate stocking rates. If you go to heavy stocking rates, other things can happen. Your plant productivity can go down. We may start losing carbon. Okay, I also want to mention some of the agroforestry work that we've done because agroforests, and this includes shelter belts, and it also includes natural hedgerows, which occur at the edges of fields, but probably of greatest interest to folks in this room is also silvopastoral systems. So for example, any mixed grassland bush pastures that we have out there, that is a form of agroforestry. The carbon that's stored within those forests also represents an enormous stockpile of carbon that's worth a lot of money. In some recent work that we just published in 2022, we did some change detection looking at how many silvopastures are we losing across central Alberta, both hedgerows, but also these bush pastures or combination grassland bush pastures. And what's really telling here, if you look at the silvopastures, which are in the middle of this graph, they represent only 20% by area. So if you look at the total land area across central Alberta, but they store more than 30% of the soil carbon across there. And that's a combination of two things that cause this. One is those silvopastures store an enormous amount of carbon, both because of the grasslands, but also because of the tree component. And together, it's a win-win, which really boosts carbon stocks. On the other hand, many of us will already know what impact that annual cropping does. As soon as you plow under these perennial systems, you're going to lose a lot of carbon. And in effect, you wind up basically burning that carbon off. Microbes are burning that carbon off, and you can go down 20, 30, 40% in carbon stock. So what this really means is that these silvopastures are actually doing far more than just providing forage. Bart was talking earlier about all those other ecosystem goods and services. There's one right there, and it's completely unvalued, and ranchers are not getting paid for it right now. Edward, yeah. Okay, but by the same token, so croplands there are representing roughly 55% by area, but they're only storing about 47% of the carbon. And that's because when you look at the carbon density within those croplands, it actually tends to be much, much lower. And this is corroborated, doesn't matter where you go globally, there have been hundreds, if not thousands of studies that look at the effect of land use change. When you take a perennial system and you plow it under, you start blowing off the carbon. It basically burns up because you heat it, you aerate it, and those microbes go crazy and start, in essence, through respiration, burning off that carbon. So depends where you are, but anywhere from 30 to 55% of that carbon can disappear. Now with no-till, we're putting a little bit of that carbon back in, but we're not getting anywhere near to what it was with the perennial systems, just to be clear. So that's that difference between those two right there. That's the decision we've made when we traded off perennial grassland for annual cropping systems. And that's one of the things that Eric is going to be drilling down into through these different rotations. How deep was the carbon tested to it? So in this system, we had both a spatial component where we took aerial photos, and I think there were 50, I'm calling them plots, but they were huge. They were 3 kilometer by 7 kilometer, and they were distributed all across central Alberta. And we mapped out every single forest within there. The data that we used in order to predict how much carbon was in there was based on a very intensive agroforestry study that was done between Scott Chang, Cameron Carlisle, and myself, where we had 36 sites all the way from Stettler clear up to Athabasca, and from roughly Stony Plain all the way to roughly Viking, where we then characterized basically how much carbon was in these different agroforestry systems, including cropland, including hedgerows, including shelter belts, including silvopastures, both the perennial grassland and the trees. So there's a lot of background data that fed into that. Does that make sense? Yeah, down to 80 centimeters or about a meter. Yeah, yes, yes, yes.
Dr. Bork, I'm just going to interrupt for a second. There are people online that are listening as well. So if you could just clarify the question when it comes in, if they don't have a microphone, that'd be great.
Absolutely. Sorry about that. Okay, so switching gears a little bit to livestock and forage production, keeping in mind I only have 15 minutes. Told you I'm not very good at sticking to timelines. Okay, I do have one project that I think will be of interest to a number of people here. Dr. Nitya Kanal, who's a scientist with Ag Canada at Beaver Lodge, he and I have been collaborating for the last 2.5 years, and we have a graduate student, Bishnu Pandey, who's getting really close to finishing his master's. He is working on the effect of plant growth regulators in terms of trying to reduce or alter seed yield in different forage grasses. The three grasses that we're working with are meadow brome, timothy, and creeping red fescue, three really important commercial seed species in that region. Long story short is these plant growth regulators that we're testing do a very good job in altering everything from plant height, stem diameter, lodging. So we are definitely seeing improvements of lodging. What we're not seeing are big differences in the yield components. So number of seeds, size of seeds, or even the bulk weight of seed. However, that doesn't mean that plant growth regulators don't have any benefits, because based on the data that we're seeing, the benefit may not be in a yield improvement, but potentially in harvestability, because if it's standing above ground and it's not lodged, there may be improvements to the harvestability and the recoverability of that actual seed. So Bishnu will be finishing in about a month. Okay, this is a really complex project that's distilled down into 2 or 3 slides. I call it the Precision Ranching Project, which is really about trying to keep the right animal in the right place at the right time. And the long, I guess, title is Can Cow-Calf Production Efficiency Be Explained by Maternal Habitat Selection, Diet, and Their Activity Budgets? So just to kind of break this down a little bit, there are 4 different key sub-projects within here. All of this work is being done basically under open range grazing, looking at cow-calf pairs. The first thing is we want to evaluate herd performance. So cow weight gain, calf weight gain, and the aggregate cow-calf weight gain, including back fat gains. We are also looking at the rumen digestive products. So VFA profile, for example, among these animals. We're also using, Bart, you talked about the green feed units, the green feed emissions management systems. We are using 2 of those units to quantify the rumen methane, enteric methane emissions while on pasture. And we are, one of the reasons we're doing this is because these animals have all been previously tested in dry lot for feed efficiency, for residual feed intake. So we have them ranked all the way from low to high. And what we're interested in is seeing whether the methane emissions on pasture reflect the performance of those animals in dry lot. And the key question I'm interested in is, do they re-rank when they go from dry lot to pasture? Are there changes in both animal performance, including methane emissions? The second component here is to understand what these animals are doing. And the way we do that is with a whole suite of different GPS technologies. Some of these are GPS collars. We also put pedometers on the animals to track how much time they spend lying down, their actual step counts, which are important indicators of their energy budgets. And then we're also using something called fecal DNA barcoding to try to figure out what they're eating and the dietary diversity of these animals. So what's that? Yeah, it's a shitty job. It sure is. And then the third component here is digging down into the cattle genomics. So there's work that Derek Bailey, for example, has already done down in New Mexico, where he has found specific markers for landscape utilization by animals. We're interested in identifying similar markers, genetic markers for dietary selection, habitat selection, and activity budgets. so that they can also become different screening tools when you're evaluating your animals. There's a fourth component here, which has been very popular and has been very successful. This is virtual fencing. We are using a no fence collar, which is manufactured and distributed out of Norway for basically autonomous remote control of cattle grazing. You can see the collars there. We are now up to 76 collars, and I'm hoping to get maybe another 25 or even 50 later this summer. I've gotten some additional money to actually expand this work. So the way this works, this is basically a big dog shock collar. You put it on the animal and it uses GPS to track where the animal is. And you can basically program the boundaries of the fences from your phone. So as long as you have cell network coverage and access to those collars, you can program it in real time. You can move the animals in real time. You can control when they access water, how they access water. We're really, really pleased with it. If you're interested in this, Alexandra Harland, my MSc student, is giving a talk for No Fence. It's an international webinar on March 22nd. So that's 2 Wednesdays from yesterday at 9 a.m. in the morning. It's at 9 a.m. in the morning because the folks in Norway are pretty much at the end of their day. So if you're interested, let me know, or I can send you or someone the webinar notice. It's an open webinar, anyone can attend.
What day again was
It is March 22nd at 9 a.m. So a couple other studies that I want to touch on. So this particular project, this is a project that Glazy de Silva, that's the Hayes Beef Chair at the U of A, has initiated, and I have the pleasure of being involved with this along with a number of other people. So Glazy is actually looking at stress biomarkers within the animals in our virtual fencing trial. And so the study is basically trying to figure out whether heat stress, or in this case, a virtual fencing stress, so the number of shocks that you might get if you're an animal, and how that actually affects their performance. The good news is in our virtual fencing trial, we're not seeing any negative relationship of the number of shocks an animal is getting and weight gain. So that's a really good thing so far. But it's a way to marry those different proposals together. I want to touch on weed ecology and management here. Okay, I got to get going. Okay, so we do have a project down in southern Alberta. This is very close to the Montana border that's looking at cheatgrass control. So cheatgrass is an annual grass that's invading in from Montana, and it's becoming a serious issue in southeastern Alberta. We've been working with Bayer, who's now Enview, to examine one of their products in Dazaflam, which is a residual soil herbicide that specifically affects the recruitment of seeds in the topsoil. Good news is we're seeing excellent results, and we're not seeing any unfavorable responses within the native plant community. So we've been monitoring this for 4 years now, and we've supplemented this with several other components, including a seed bank analysis. We're doing some greenhouse work to look at perennial grass seedling tolerance to indaziflam, and we're doing some work at the Matthias Ranch looking at native forb seedling establishment. So there's a whole bunch of pieces built into there. New projects. I promise I'll be quick. Okay. And I left out a lot of projects. So I do want to mention the Alberta Agrisystems Living Lab. So this is the living lab that's led by the Alberta beef producers. I have the pleasure of leading the grazing component. We have recruited a number of different practitioners in Alberta right now for this. The primary BMP, so beneficial management practice that we're looking at, is adaptive multi-paddock grazing. We'll be looking at everything from the agronomic responses in these pastures to carbon stock, carbon stability, and also greenhouse gas fluxes. So there's a whole bunch of elements here. I also have 4 or 5 producers that are interested in overseeding or interseeding. And I think Bart had mentioned that a lot of producers are interested in that as well. So we may run a separate side project on that. And the goal here is really to track real changes in these metrics over time, pre and post treatment. That's the difference from our former AMP study where we did a snapshot study. This is true change detection, if you like. There's a parallel project called the Central Plains Living Lab that both Cameron, Carlisle, and I are heavily involved with. This is through SODCAP out of southern Saskatchewan, although there are sites in Alberta as well. We are working very closely to harmonize both the AALL and the CPLL. So we're collecting the same data and we have a more powerful data set between both of these projects. And there's also another project that Cameron is helping lead in Saskatchewan that's basically mapping soil carbon across all hayland and pasture in Saskatchewan. This is a very ambitious project and it's running for 5 years starting last year. So I'll just throw that out there. And then the very last study I wanted to mention, just because I think it's a really cool project. This again is being led by Dr. De Silva. This is basically a fetal programming study. This is funded by BCRC and it's going to be starting here in the next 12 months. So the idea here is very simple. If you have a cow and she is gestating a heifer calf and she's under stress, the question is, will that affect the longevity and reproductive efficiency of that heifer if you recruit her into the herd down the road? So if you have a cow that is really healthy and not nutritionally deprived because it's not, for example, overstocked or something, how does that translate into better herd performance because of the recruitment of those heifers? That's in essence fetal programming, which is a really interesting concept. So it's kind of feedback based on what you're exposing the maternal herd to, based on how it feeds back through the quality of those heifers that you get back. Okay, I know I probably went over. I apologize. I tried to go quick. I'm happy to take any last questions or comments. This was a lot. I didn't cover everything, but I wanted to give you a flavor for what we're doing. Yeah, Graham. Oh.
Sorry.
It's hot.
Yeah.
Hot mic, yes. Your numbers on your economics, you've got good data coming out of those studies. The question is, how much of it is marketable? How much of those studies do you have to take a haircut off for it to be real risk of reversion, risk of management changes? So you've got a conservative number being put forward rather than your gross number.
Oh, that's a loaded question. Okay, so I would agree, Graham, that maybe these numbers are shock and awe in part, but I think they are realistic. Okay, there's going to be confidence intervals on them. Fair enough. I'm the first one to admit that. But I think the first thing is to really understand just how large the carbon stocks are that are, for example, within the agroforestry systems or within these perennial grasslands that are at risk from land use conversion. So we have to be realistic as a society around that. That's the first point. The second point, I think, is more nuanced, which is what realistically are we going to get paid for, right? Or what can we make the argument that we're going to get paid for down the road? And I would say that's all a matter of willingness to pay. And who's going to determine the willingness to pay is really going to be the consumer in the end. So I guess my thinking all along has been to create, if we can create such strong data sets that senior policymakers, God forbid politicians, they can't turn a blind eye to this, that they have to see it and they can't ignore it. And if we get this information out to media, because I've done a lot of media hits where I've talked to different groups, including international media in the US, they are stunned when I start telling them that a healthy soil takes up methane, for example. They're like, what? I didn't know that a healthy soil, how can a healthy soil, what? A healthy soil takes up methane? So then we talk about, a methanotrophs in the soil and how there's actually net uptake in a healthy soil. And we go through that whole spiel. Many people and in fact, most members of the consuming public, are not aware of that. And secondly, the media are not aware of it. So we just got to keep getting that message out. And Bart made that point. We got to keep hitting it. We have a lot of really good things to highlight. We just have not been doing it enough. And in the end, consumers are going to make the argument. And I've had students ask me this. I've had reporters ask me this outright in webinars. They say, you know, should I eat beef or not? And I say, you should eat beef, but you should think about where it comes from, because you can have a profound influence on land use footprints, and you can help conserve habitats. You can help store carbon. So those are the questions that we need to have people thinking about, and that opens people's eyes.
In your research money, are you planning to spend money on actual protocol development, taking your research and actually doing the work to make a saleable product to capture the numbers that you're talking about?
I'm not, because that is way over my head. So here's the way I see my role here. And maybe I'm being a little bit naive on this, but I see myself as an information broker. I want to provide as good an empirical basis on carbon storage, biodiversity, all those kinds of things. I'm happy to be involved in that process because I have my own ideas, but there are senior economists and you know, including at my university, that have far more experience, like Vic Adamovich and Scott Jeffrey, that have the ability and understanding of these markets. What I will say is I used to think that the change for these ecosystem goods and services would come from the top down. I don't believe it anymore, because I think we are generally, we have a senior political system and policy system that doesn't want to pay for something that we're already getting for free. I call it the additionality roadblock. I think it's going to come from the bottom up. It's going to be driven and demanded by consumers, which is not a bad thing in the end, because that means that it's going to come directly from people that are willing to put the money where it needs to be. So. Hang on, we got to bring the mic up.
Just got to bring the mic,
I'm
please.
learning.
Thank you. This is not a complicated question, but would you go back 2 slides? You flipped through the last part really fast, and I saw carbon sequestration, and I would like to just know more about that. There it is.
This one?
Pasture. There, that's the one, and I will just take a second and write it down, and that's really all I need to.
Okay.
Thank you.
Yeah.
We are also checking for questions online. Doesn't look like we have any questions online, so.
Lots of good stuff going on at the U of A.